7C, we're going to do confidence intervals for proportions. So instead of wanting to know the average number of something, we want to know the percentage of people or things that fit a certain category. Okay, so the example we're going to look at, we have a survey of adults. 64% said it is acceptable to check personal email at work. And we want a 95% confidence interval for the population proportion. So out of all adults, what percent of them think that it's okay to check their personal email at work? Okay, so we're back in Desmos. All right. This time, it's still in that inference category, but this time we're looking under categorical data, and we're going to choose the z-test for proportions. Okay. In there, we need to enter the number of successes and the sample size, and then we can do our confidence interval. Okay, so I'm going to hit my plus sign, go to inference. Okay, z-test for proportions is the one we want now. Okay, and it asks for two things, successes and sample size. So sample size is 989. That's the number of adults. Now, when we do these problems, sometimes it will tell you the number of people or objects, and sometimes it will tell you the percent. In Desmos, you have to put the number. So if it gives you a percent, like it did in this problem where it says 64%, we have to figure out what that number is. So what is 64% of 989 people? So I'm going to do that math down here. Okay, 989 times 0.64. Okay, and that tells me that there is 632.96. We're always going to round these to a whole number. Normal rounding rules, so the 9 tells me to round up, so I'm going to put 633. So when I do my test, I'm going to put 633, not 64, not 64%, not 0.64. I have to have the number of people. Okay, so if it was 64%, it was 633 out of 989. Okay, so then create the test and do my confidence interval. We want 95% confidence interval, so we have to change that number. So our interval is between 0.61 and 0.67. All right, so that means that somewhere between 61 and 67. And now we have an updated survey 6 years later. It says 762 of 1114 said it's okay. And we want to know if this gives us evidence that the proportion has changed. All right, so basically we want to know, is this percentage outside of our original interval? So 762 out of 1114 is 0.684 or 68%. That's outside of our original interval. So that means yes, this does give me evidence that the proportion has changed because it doesn't fit in my original interval. All right, then just like with means, we can do a minimum sample size. This one has a different formula. Okay, so p hat and q hat are the probabilities of success and failure, just like they were with binomial. Sometimes they will give you a preliminary estimate. They'll say, we think this number is somewhere around 42%. And then you use that. But if not, then you use 0.5. Okay, and it's the same rules as before, where together they have to add up to 1. All right, Z sub C is just like it was in 7A. Here's the 3 most commonly used Z-scores. And then E is the margin of error. Okay, so we'll do an example problem. All right, we want to estimate with 95% confidence the population proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the population. So that 3%, that's my margin of error. Okay, any percentages we're going to put in as decimals. So that means my margin of error is 0.03. Okay, so with no preliminary estimate, all right, let me get rid of all this stuff. Okay, my minimum sample size is going to be p hat times q hat. So that's going to be 0.5 times 0.5. Okay, I'm going to use 0.5 for both of them. All right, z sub c. Okay, so for a 95% confidence interval, my z-score is going to be 1.96. All right, so 1.96 over my margin of error, which is 3%, so 0.03. And then that needs to be squared. Okay, so I got 1067.11111. Remember that for minimum sample size, we're always rounding up to the next whole number. So I would need a sample of 10,068 people, or 1,068 people. Okay. Then they say, you know what? We know from past results that p hat is probably somewhere around 0.31. Okay, so now we have a little bit more information, so we can make our estimate a little bit more targeted. Okay, so my p hat is now 0.31. Okay, and q hat has to be 1 minus that. So it would have to be 0.69, so that together they add up to 1. And that drops my sample size down. So now I only need 914 people because I'm a little more sure about what my numbers are going to be. Okay, and that's it for 7C.